Hello everyone. Today we are going to use a photoresistor. Okay. So what is a photoresistor? Basically, it is a resistance which depends on light. We also call this as an LDR, light dependent resistor. So let's see it's working. Okay. So the resistance of this particular resistance depends on light. Like if you use a potentiometer's resistance basically depends on the wiper where you have moved the wiper. But what about the LDR or the light dependent resistor or a photoresistor? It is dependent on light. Okay. Let us first of all connect it to a load. We'll take an LED as a load, and let us use this photoresistor to change the brightness of this particular LED. Okay. So let's first of all let's have a battery here. Let me have it like this. Then we will connect the positive to the okay. How do we connect the photoresistor? Is basically we connect it in series with whatever we actually want to control. So we connect it in series. So how do we connect it in series? We connect one end of this particular photoresistor to the load, one end of the load, and the second back to negative. Okay, is it okay? Is the connection okay? No, it is not okay. We have connected the A node with the negative. So what do we need to do? We can just swap the battery. Okay, sorry. Let us swap the battery on its sides and then connect the negative here and here. Sorry, positive here and the negative. Now I feel that the connection is okay. So positive is this side. Let us make this as black so that it is proper. Let us make this okay. No problem. Let's make this as any other color. Beautiful. Okay, now let's start the simulation. When we start the simulation, you can see that the LED has started glowing a little bit. And when we click on this photoresistor, if you increase the brightness on the photoresistor, you can see that the resistance decreases. And when the resistance decreases, it allows more electricity to pass through and the LED glows more. And if we go towards darkness, if this photoresistor goes towards the darkness, it gives more and more resistance. So what is the basic work of the photoresistor? The more is the brightness, the less is the resistance. Okay, you can figure it out now. Now, why did I not connect a resistance with this particular LED? We have already connected a resistance, and a photoresistor is also a resistor, right? So it is also, so it is connected, already connected. So we don't need any other resistance. You may put, you may not put. Okay. So this is the basic circuit of a connection of a photoresistor with a load. Let me change the load. Let me make the load as a motor, maybe a DC motor. Okay. So let's connect the DC motor with this. DC motor doesn't have any problem with positive negative. Okay, well, let's have it this way and let's connect it. Okay, so the DC motor has terminal 1 and terminal 2, so it doesn't have any positive. Let's see how things happen now. So that means what is the photoresistor going to control now? It is going to control the speed of this motor. So let us see. The speed at the moment is very less. It is 6 revolutions per minute. It is 6 RPM. And if I increase it, if I take it to the right hand side more and more, so the resistance is less and less, so it allows more and more electricity to pass through. You can see that the RPMs are now increasing, increasing, and so on. If I take it to the left, if I take it to the darkness now, it is now 6 RPM. It allows electricity to pass through at even the darkest thing, but the electricity is very, very less. It's allowing only 6 RPM to pass. So now this is the normal connection of a photoresistor. Basically, for if it is connected without an Arduino. Let us now use an Arduino. So we are using an Arduino. I don't need a battery. I just need this photoresistor number one. Let us use a load. The load may be an LED. Let us use a breadboard. Okay, a breadboard and an Arduino. Alright, so how do we work on this now? Let's power it up. 5 volts goes to positive, ground goes to negative. No problem there. Let's color them properly. This is negative. This is positive. Now, what we do now is basically we connect, we, alright, we connect one end of the photoresistor to the positive, and we connect the other end to an analog pin because it is now giving me an analog input to the so let's color it differently. So you can see that it is now one end of the photoresistor is connected to the positive, and the other end is actually connected to the to an analog pin. But there is one more connection that we need. We need to connect the the pin which is actually connected to the analog pin. We will connect that through a resistor to the ground. So let's have something like this. So let me connect this through the resistor, and I can say to the ground. Okay, so let me connect, color this black, let it be green, no problem. So you can see the connection now. This is how we always connect. One end of the photoresistor is connected to the positive. The second is connected to the analog, to any of the analog pins. But the second pin is also connected to the negative using through a resistance. This should be very clear. I'll say this again. One end of the photoresistor goes to the positive, it has gone to the positive. The second end, one line goes to the analog pin because it is going to give input to the to the Arduino. But the same pin is connected to the ground also using an a using a resistance, normal resistance. Let us bring this also somewhere here. I need a resistance. Let's put the resistance here. And this is my anode. Anode is positive. Okay. The anode I'll connect to the pin. Okay. So let me connect it to the pin. So let me connect it to a PWM pin. Why? Because I want it to go bright little by little. So it is again an analog kind of a thing. Uh, the negative side of the LED is connected to. So let us connect it. So this is how you would basically connect anything uh, uh, using an LDR or a photoresistor, a load. Okay, we'll connect another load in a few minutes. Don't worry about that. But let us now see how to program it. We are using two pins. We are using A0 and we are using a PWM pin. That is number 6. Let us see now how things should happen. Okay, how many pins are we using? We are using int LDR pin is equal to A0, and int LED pin is equal to 6. Alright. Let's specify the pin modes. Pin mode LDR pin, comma, we are taking input from the LDR, and pin mode brackets में LED pin, comma, output. Alright. Let's say int I create a variable called var, and I say var is equal to, var will get a value of what? It will get an analog value, analog read from LDR pin. So LDR pin is going to give it a value. Alright. Now the same value is going to be used for lighting up the LED now. So I'll basically write analog write in brackets LED pin, comma, we will write var at the moment, and let us have a delay of say 1 second. At the moment, we have taken, what we have done is we have read the LDR pin and stored it into var, and it's the same var we are going to write to LED pin. So it will get as bright as whatever the var is getting the value. Okay. Let's see now. If I increase this, the brightness is increasing. Is it increasing? Okay. So let us see what the values of var is. Value of var is here. So serial dot println, because I didn't think the var this is getting a proper value there. Let us see. Serial dot begin and the 600. Okay. Let us see what is the serial monitor telling us. It is giving me a 6, giving a 252, 294, 95, whatever. And the maximum it is getting is a 679. Okay, so the minimum here is a 6, and the maximum is a 679. Alright, let's change the code now. We know how to map these values now. We will use another variable called var2, and let me stop the simulation. Okay, and we need to map these now. We'll say var2 because the original values are from 6 to 600 something. So we'll say is equal to, we'll say map var, which has a value from 6 to maybe 600 or something, and it should change to 0 to 255. Okay, and we'll say analog write var2. So whatever is the new value with that has been mapped. So if the input is coming as 6, it will make it 0, so the LED will be off. And if it is the value of the reading is 600, it will actually get a 255, which is okay for our analog read. Let us now run this program and see how things are happening. So this is minimum at the moment, so it is giving me the LED is off. So if I increase it, the LED will go brighter and brighter. Alright, it should have gone brighter. Let me see what does it actually show as on the serial monitor. On the serial monitor, if you increase it, did I change that to a var2? Okay, I have not displayed var2, so let me display var2 also. Okay, start the simulation and let's see what happens now. It is giving 6 and a 0. Yes, the input is 6, output is 0. And if it is input is okay, so it has gone beyond 600. So it's actually 679. I think it's around 680 or so. So let's change the map. It is map is actually the actual value that it is getting is around 680. Start the simulation, see what happens. So minimum is this and maximum is this. Perfect. So let us see our values. See, minimum is when the minimum is a 0, minimum is a 6, it actually makes it a 0. Okay. If it is in between, it's around 500 and sorry, whatever. It's not giving a linear kind of a thing. So maximum, if it is 200 and 679, the output is 254. So you know now what the map thing works. Okay, how map works. So what did we do? We took the input from the LDR pin. We mapped the values. We just checked with this through the serial monitor. We checked what is the minimum and maximum value which we got from the LDR, and we got 6 to 680, and we are mapping it to 0 to 255. You know why? Because 6 being a PWM pin will only use values from 0 to 255. I'll write it down here, 0 to 255. Whereas A0 pin is from the LDR, it is getting minimum value as 6 and maximum value it is getting as is around 679. So this is why we mapped it this way. Okay. All right. So the main thing is the LDR needs to be connected one pin directly to the positive, second pin directly to the analog input pin, and the second pin which is connected to the analog pin is also connected to the ground using a resistance. Let us now use another load. I'm going to just remove this load and use another load. I'll remove all this. Okay. And another load, probably again a motor. So I'll use a DC motor. And DC motor, let me connect it directly to the pins here. And we'll connect one of these to the ground and the second one to pin number 6. Okay, so I think this should work now. Let us see. Start the simulation. And it is showing at as 0 RPM. Why? Because now 6 is actually mapped to 0. We know that. We have used the map function now. So let me just increase this now. So when I increase this, the RPM increases and it goes on and on and on and on and on. Yeah, so it has overloaded. Yes. Okay, so anyway, we don't want to overload this. So for overloading, we basically need a resistance here again over here. But you have seen now how things have happened. How can we actually use a photoresistor to actually control something? All right, to control something. So we have used two loads. We started off with LDR without the Arduino, so that direct connection is just a series connection with the load. We used an LED as a load and we used the DC motor as a load. Then we connected it using Arduino, and using Arduino actually it will the LDR is actually connected one pin directly to the positive, second pin directly to the analog pin, and the second pin also connected to the ground using a resistance. Baki, on the other side, whatever load you use, that it hardly matters. We don't care about it. Okay, I hope you have understood this. I'll see you in the next video. Thank you for watching.